to hopefully a bit better version of this seminar than yesterday, where I did struggle a bit with the technicalities. Hopefully a bit better version of this seminar than yesterday. And of course I have a bit of issues again. It should be fixed. Okay, so let's see. Let's let people be able to join just for a few minutes. And yeah, I've had some time to rethink my setup here. So hopefully you can all hear me now. So would somebody just reply and tell me if the sound is loud and clear? I'll just wait and see in the chat if everything is okay. All right. I would just loud and clear. That's great. All right. Let's start. So what I want to discuss now is sensory methodology as such, and how we at the Coffee Mind, we've been working on this for more than 10 years now. We recently released a new one-day sensory performance for coffee roasters that specifically basically zooms in on your personal skills in identifying and describing relevant aspects of coffee roasting modulation. So coffee roasting modulation, if you change things during roasting, how does it show up in the sensory properties of the coffees? And this is something we've been looking into from a sensory and even chemical perspective for more than 10 years now. We've got more than 15 scientific articles on the topic. Yeah, so that's I just want to get a bit deep in sensory methodology as it's done in the general community of coffee, and particularly for coffee roasters. And as you can see here on this slide, it says how to improve your sensory skills with sensory science methodology, or how to avoid tooth fairy data and overcomplicated paperworks. Tooth fairy data points to the fact that people are using kind of the concept of subjectivity to colonize a kind of a power domain, which is taste. What is good taste? What is bad taste? And try to kind of colonize this hazy area and instruct people on how to think. And for me, that's a bit like tooth fairy, that you make kids think that you have to behave well and that you get more money from the tooth fairy. So that's a bit of a comment here. And also the paper pile, for me, many of the most widespread sensory training systems ask you to fill out a lot of paperworks and kind of alienates you from the coffee that you're tasting by filling out things that you don't understand. Nobody does, but if it has a nice design, people are convinced. So a bit about Coffee Mind. Probably you already know us since you are here. We've been specializing in coffee roasting and sensory analysis, and we do education, consultancy, and research. Ida Steen was with Coffee Mind for more than 10 years. She's now in a biotech company Still actually a Coffee Mind sensory scientist, but only in her spare time. We've done a lot of training over the years. I've been training more than 2,000 individuals, coffee roasting and sensory skills since 2007. And this is in small groups, so I've been speaking with a lot of people, and I've consulted more than 30 roasteries worldwide. Been running more than 30 scientific research projects, of which 15 are now scientifically published. And we've focused on sensory evaluation, particularly for coffee roasters. If you don't already, please scan this code and get some free education on Coffee Mind's podcast, where I'm going really deep in theory of science, and that's really worth a listen. So first, I'd like you to understand what sensory science is. Sensory science cannot help you with, it cannot tell you what to do, and it cannot help you with your business plan. So you need to make your business plan and decide who do you want to address and why with your products. And once you have done that, then sensory science can help you with finding relevant samples that has where you can start to do some experiments. You can do a product range, or you can kind of optimize, whatever that means, a particular product. In the process of optimizations, it's important that you are creating a set of samples, and they need to be, the flavor differences needs to be big enough to be relevant. And so according to sensory science, there are 3 steps that you need to make in your process. And this is what's called a stage gate model, where you are first focusing on one question and you have a specific method to answer that, which is, are there any relevant differences between the samples that I'm going to put into this experiment? And if it's a yes, you can go to the second stage, which is describing the difference. And once you have described the differences, you can start to do your consumer data, where you are throwing these samples up against different consumer segments, and then you will learn who likes what, which you can use strategically in your business plan. So you can decide to, you can use these data up against who you've decided to scale your business up against. This is sensory science. It's really simple. It's only these 3 questions in a sequence. And just to show you, okay, I was just worried that the stream was, but it seems like it works. Yeah, so in sensory science, it's very important that these simple questions has simple answers. Complexity is not something that you want at all in sensory methodology. You really want simple questions and simple answers, and that's why there's this stage gate model that I told you. A simple question: are they different at all? How are they different? Who likes what? That's the 3 questions that you ask in sequence, and you have some simple answers. Are they different at all? You can use a triangulation cupping, where you are testing if people are able to pick up the differences between the samples at all. If they are, you can go to the next question on how are they different, and here you're just scoring the intensity of an attribute from 1 to 10. And once you have those data, then you can go to a consumer segment, and you can start to map the preferences, which is typically on this 9-point hedonic scale. And then you can do a lot of advanced statistics, but the questions and the answers needs to be really simple, because if they are not, you don't understand what you're doing. And this is a very important point for the next slide. So it's very important on this slide to kind of really contemplate that for beginners, for non-scientists, this is such fundamental, simple questions that there can be no doubt about what you are asking about, how to answer it, and how to interpret the data. And another aspect of this, you can see here again, discriminative, descriptive. That is laboratory work where you are measuring properties of the food substance. Once you are done in your lab, you're going to the field, right? And here you are asking different customers about how they react to these samples. And it's very important that that you understand that discriminative and descriptive, that is properties of the product, where once you are done with that, you would go to the customers, and then you will see how they react. So now you're measuring preferences about the people. So it's not preferences, it's not properties of the coffee anymore. It's actually properties of humans. Very important. So this cannot be done in the lab. You could do some estimates, but that's often when you do estimates, you really miss important information. So it's not recommended to think that you can predict what people like. We have done this a lot, and it's very, very, very difficult to predict anything when it comes to consumer behavior and consumer preferences. So just to give you an idea of the simplicity of those questions, you can see here that if you just imagine a really light and a really dark roast. The really light is 100 actron and the really dark is the 50 actron. Everybody knows that acidity is high on the light and bitterness is low on the light roast. And bitterness is high on the dark roast and acidity is low on the dark roast. So if we ask a group of people who we calibrate for bitterness and acidity first, it's just serving in watery solution, citric acid for acidity and caffeine for bitterness. It's very quick and easy to calibrate people. And once they are calibrated, you can ask them, raise your hand if you think sample A is most acidic. And you will probably see everybody raise their hands, because intensities is something that is an absolute, in a sense, property of the product. Where if you ask the same group of people, raise your hand if you prefer sample A, you'll get a very mixed result, because people don't agree on preferences, even if they are calibratable on intensities of descriptors. And as I mentioned in the beginning, there's a bit of a loophole for people who want chaos. Some people, I think it must be something with control, that if you have chaos, you can be the one calling the shots when it comes to what is good and bad taste. I don't know what it is, but this is inspired by a French sociologist called Bourdieu on kind of how to capitalize taste, in a sense. So the loophole is that you say, well, sensory data, that's subjective. And then you can just make endless forms and courses where people are feeling this is a hazy world and we can kind of calibrate by agreeing and so on, which is a very unfortunate situation, I think. So I would say, based on inspiration from research design, or more particularly theory of science, actually, and most particularly by phenomenology by Husserl, who talks about intentionality, that knowing is a subject knowing something about an object. So the subject in science is the scientist. So subjectivity has got nothing to do with the object of investigation, which is the person tasting the coffee. So as long as the methodology is solid, it gives you objective data, even about people's preferences or about intensities. So objectivity is something that is kind of grounded in the method. So if the method is good, regardless of the observer, so regardless of which scientist would execute the experiment on the consumer group or in the lab mapping intensities, you would get to similar conclusions, because the method guarantees this. So the subject is actually the scientist. And the object is the person tasting the coffee. So we are gathering first-person data. Don't call it subjective. It's just confusing. It's first-person data because you ask the person, and the person report back directly either intensity, which is the lab, that's for professionals, or it's consumers telling you about preferences. This is very important, and I really hope that this slide will actually be a huge support for clearing out the mess, I would say, in sensory education that we have worldwide right now. So remember, it's pretty simple. You need to, in order to do an experiment, you need some relevant samples, and we can test that with discriminability. And we also can describe then the differences once we've found a relevant set of different samples, and we can see who likes what. Notice here, there's no bureaucratic centralized concept of quality. And here I'm talking about SCA, the old and the new form, and the Q system, which is a bureaucratic centralized concept of quality. That is nowhere to be found in science at all. So those are systematically not scientific methods at its core. And I also, so one thing, it's not scientific, that's one thing, but it's actually also deeply confusing and kind of turns everybody into followers rather than leaders of their own organization. So I think it's also practically sidetracking. All right. So rather than talking about quality, I would rather talk about suitability. And you can see here we've got some small business cards here with, just a second. We've got some small business cards here with, yeah, I can just show you the next slide, where basically we have the flavor categories of the flavor wheel we put in this spider plot. So we can, for different samples, if I'm, for example, selecting greens for clients, I would bring a stack of business cards and I would fill out just the relevant information I find that is all guided by the purpose and the business model of my client. So these are relative scorings relative to the samples at the table, and then the basic tastes are also to be scored. And once we've found the relevant products based on the flavor category intensities and the basic tastes, then we'll also bring some 3 flavor notes from the outer part of the flavor wheel for the marketing department. But most often the decision is made based on flavor categories and basic tastes, because the further you go, the more specific you get, the more you are in fairy tale land. And you can see here it's pretty simple how to fill these out. And I don't need to fill all of them out. I just need to use them for taking notes. And you can also, once you have your products, you can start describing them or comparing them in something called a napping here. It's inspired by a scientific method, but we are not doing all the steps in the scientific method. We're just kind of brainstorming, tasting the coffees blindly and putting them on categories. And once we've done that, we see if we can kind of get some flavor notes and get the information we need, which is just a really if you trust your own sensory skills, these are really good data for putting on bags, and it's great to compare them and have something like a flavor wheel as your reference. It doesn't need to be coffee minds, of course. There are countercultures or SCAs or even the old Ted Linkle can be used. And sometimes if you find a flavor that's not on the flavor wheel, then you can put it on anyway, but it's typically a good reference. So let's look at the new SCA cupping form, because I think many people are concerned about this or trying to figure out what this is, and they claim it's scientific. So let's see about that. I already explained you something about science, and if you remember this slide, you can see simple questions and simple answers. And once you have a lot of simple answers to simple questions, you can do some really advanced statistics. But if you don't have simplicity in the questions and the answers, it's very confusing, and it doesn't give you good data, and it's kind of anti-science. So you can see here, I'll go into each of them individually soon. But you can see here, just looking at it, you can just see it's way too overcomplicated. So there's an aspect of theory of science where, well, now we are talking about complexity versus simplicity. So what to prefer? And very rarely people are challenging methods in the specialty coffee community, I think, with simplicity. And you can see here that simplicity is advised by a principle called Occam's razor in a theory of science. So because there's a strange fact about different types of models. So normally you think about a wrong versus a right model, right? But Occam's razor says that if you have two different explanations explaining the same thing, choose the simpler one. And that's very rarely done in the specialty coffee community. You can see here, this is an example where you've got the solar system. You can assume that the sun is in the center, in which case you get some really nice circles to explain the solar system with. But you could also assume that the Earth is in the center. That was the first assumption in astrology or astronomy. I don't know which one is the scientific part, one of them. But you can see here, the interesting thing about geocentrism, where you assume that the Earth is in the center, is that it's not wrong. You can make a perfect mathematical model that predict all the planet positions perfectly. So it's not that it's wrong, but it's just, it should be the simpler one should, according to Occam's razor, be preferred. So simplicity beats complexity if the complexity doesn't add anything. And typically complexity doesn't add anything in terms of intuitive understanding. It actually removes, because all of a sudden you can't make your own decisions because you kind of lost the overview of what's going on. And because sensory science is an engineering approach, and I've just recently kind of understood how this permeates mechanics, such as cars and electronics, and also programming. That it's very important to have some simple units that fits in a broader context. And if there's any doubt of each individual unit, if that's not simple, it's very difficult to make the whole vehicle, if it's a car, make it work, or if so there's something in the electronics. For example, a cable needs to be very simple. It just needs to passively transmit everything. And yesterday I had flickering, and I've got like 7-8 cables here, and I did not know which one it was. So just the one link in the chain of such a complex system here makes the chain break, right? So if there's one unit that creates noise, the whole system breaks apart. And it's exactly the same when you're doing a sensory experiment or try to gather sensory data. It's very important that you don't overcomplicate and you have simple steps in your process. And it's also very important not to, well, to change anything, right? So we've got the classics in science. We've got Newton and Einstein and Niels Bohr and microeconomics and sensory science, right? And the simplicity and the precision with which the simple concepts correlate with reality, it's so crucial. And if we're just tweaking it a bit, everything is lost, right? That's you saw here, right? If there's just one link that is kind of not exactly simple and correctly placed, the system breaks down, right? So the whole point is, don't try to improve the classics. So here we've got two classics. And if we try to kind of just make our own version, if I have a car and I want to make my own car battery, why would I do that? Because for sure I'm failing, because all the small details, it needs to be really simple and well proven. So if we have some classics, don't think that you can improve them by adding a layer of your own creativity. And this is indeed what I think has been done with the new SCA system, that we have some classics and they say that they use microeconomics, which is 100 years old, and sensory science, which is 50 years old. They say that they've used recent insights into sensory science and economics. It's not recent, it's old classics. And then they are tweaking them, right? There's a lot of things left out from the microeconomics, and there's a lot added compared to sensory science. So it's really not a very, I think, nice addition, because it's just not at the level of the classics. And also, if you've got one overcomplicated form that you want to be able to do everything, they say the full value chain mapping, which it isn't, because bitterness that is modulated a lot in roasting and brewing is just a tick box. So you cannot track the value that the consumer puts on the descriptor bitterness in itself. One of the most important attributes of coffee that is modulated highly during roasting, highly during brewing. So if bitterness is not scorable on an intensity scale, then there are some assumptions behind building the form that's not made explicit. And it seems like it's hanging in the old form that was made to only assess green coffee that was always roasted to Acton 63. But even different coffees have different bitterness. So even if you roast them to same roast degree, a consumer would, if they can taste differences in bitterness, some would prefer it and pay more, and some would hate it and pay less. So they claim that it's a one-size-fits-all, but it isn't if you look at it. And even if it is, a one-size-fits-all is a really bad idea. And this graphic shows you that science is simple questions with simple ways of answering it, which is the methodology. So form follows function. You really need to make sure that you pick the tool for the task at hand. So science is on the left, where you have some simple tools, which is simple ways of answering simple questions. And on the right, you have these big forms, one size fits all. It's not that you can't use it. It's not completely useless. You can actually, if you have a tool like this, you can knock in some nails, but it's not very nice work. And often you fail and you don't understand why. Because the tool was sold as a good tool. So that's just a way of trying to illustrate what happens if you try to violate the classics by making your own overcomplicated forms that doesn't have this simple yeah, simple question, simple answer, and in specific stage. First you answer one, then you go to the next, because if there's no difference at all, why would you try to describe them? All right. Yeah. So you can see here the old 2004 SCA copying form and the 2022 is just overcomplicated, because this is from our sensory software. You can see if you in a research project you score a sample, you would just score them all the same scale, right? And you would feed the session with only the relevant attributes. You don't want to waste the time of the panel with attributes that are not relevant, because then you are just confusing people. It takes way too much time. So when we do a research project, we are struggling to get the descriptor count down to below 10, hopefully 8. Sometimes we have to do 13, but then we need to kind of only do 5 samples in triplicates. That's 15 cups rather than 6 samples, which is 18 cups. Because if you need to score 18 cups with 13 descriptors, it's very tough. But our panel can actually do that. I can show you that later in some data. But the important point here is that you can see the simplicity of the scientific way of working, which is on the right, from our sensory software when we do research projects. And the forms on the left, they look, I hope that you kind of recognize this, right? The difference between overcomplication and simplicity. Very important. You get really bad data if you don't. And then you can see here, if you need to score 3 samples in the hedonic form, that should have been the consumer data from the new SCA CVA system. You can see here, if you need to score 3 samples, you can see here fragrance, aroma, flavor, aftertaste, acidity, sweetness, mouthfeel, overall. What is the quality of acidity anyway? So impression of quality. The impression of the quality of acidity is such a vague concept that it's impossible to calibrate people on. And the quality of sweetness, it doesn't make sense. It should just be how much do you like it or not. So in our consumer module in our software, we just have how much do you like it. It's a like it scale. You can see consumers, they are quickly done with the model on the right, where the one on the left, it doesn't look like it's supposed to be filled out by consumers at all. Well, and then again, it's a bit weird to have a consumer part that's not supposed to be filled out by consumers. That is such a big deviation from sensory science that I just kind of go back to this picture to kind of, that's the best way I can illustrate that. Don't make these creative adjustments to the classics, because you will end up with a system that nobody understands. And even if they create data, nobody really know how to execute or interpret the data. So again, you can see the descriptive form, the SCA way versus the scientific, and the hedonic form or affective form, the SCA versus the scientific. And I hope you recognize the difference here again. All right, so how to actually do such a descriptive analysis? The way to do it, so now I'm showing you how scientific data are done in the descriptive. How is a scientific descriptive test made? So that creates a lot of, it's a huge data set, but it's just based on a lot of people or a panel, preferably 10 to 12, preferably 12 actually, scoring intensities of a series of descriptors, and so they'll have a lot of these to score. So you can see here, let's say that we want to describe It could be 3 different roast degrees. It could be 3 different types of coffees roasted the same. And we want to indeed describe the differences. So here you can see that each sample will be served in triplicates, because it's very important that each assessor doesn't know what they are tasting at all. And then it's randomized so that they have no idea what they are tasting and when. It's also blinded so that they just get, each cup gets random numbers. So you can see here it's 3 samples turning into 9 subsamples, because there are triplicates and they are randomized, and even each person has their own individual randomized sequence through the sample set to make sure that there are no confounding factors, so that each cup is always tasted from a random other cup so that there's no carryover effect, and we also get better distribution around the table. And you can see here they are all scored on the descriptors that has been chosen for this session specifically. So before doing a session like this, there's a small group that it's called a descriptor development session, where we are typically 4 people. We're typically 4 people scoring these. Or not scoring them, but deciding what attributes needs to be included in the session. And it needs to be the attributes that we think is best at describing the differences between the samples at hand. So you can see here at the university, it looks like this. But for 10 years, Ida and I, we've done this. So we've developed a way to get this done in a much more informal setting. And we've created a lot of projects like this, and we even have a scientific paper in these days that proves that the way we do it creates some excellent data. So we can do scientific descriptive analysis in CoffeeMind. So I want to show you a data set, but before showing this, I want to make sure to explain to you, in a sensory descriptive analysis, you have such an amazing data set that can tell you the most interesting things you can know about the samples and the differences between the samples. The other thing it can tell you something about is each and individual cupper. So if you were here and participated, you would get the equivalent of a hearing test per descriptor, your skills in handling that descriptor in a session where you don't know which sample is what. So you've got excellent data about the product, excellent data about each and individual cupper, and that who can get like a skills assessment, like a hearing test. But there's also excellent data about panel calibration or lack of calibration. So I'll show you these 3 sections of our software. So we've created our own software to handle this internally. So basically, I've just taken everything I've seen at the last almost 15 years that I've been working at the university, and I've just created, taken all the types of analysis I've ever seen and just integrated in our own software that can easily plan a session. That's the descriptor development, and also gather data from the assessors and also do the analysis in no time. So I want to show you a data set here that is actually almost the most interesting sensory analysis I've ever seen. It is different types of coffees grown in the same greenhouse here in Denmark. It's the university greenhouses where you can control oxygen level, CO2 level, humidity, and temperature. So you can make the trees think they are in different altitudes. But this experiment, they are just at the exact same circumstance. So they get the same, they have exactly the same treatment. So any sensory difference between these samples has to do with the genetics. So the sensory differences you see on the coming slides is shifted purely by genetics. Really interesting. And this is done by Rasmus, who is behind POMA, who is doing research here in Copenhagen, Denmark, in a greenhouse. So there's a lot of interesting data coming out, and this was the first sensory descriptive analysis we did on those samples. The first you see when you do a sensory descriptive analysis, the first most interesting plot is called a PCA biplot. It sounds very fancy and it's top shelf multivariate statistics, but you don't need, it's not too fancy in the sense that it's very easy to understand how to read it. So you can see, again, it's simple answers and to simple questions. You can see the question is, how does the coffee taste? And the coffees, those are the blue dots here. So you've got Robusta, F1 Hybrid, Caturra, Liberica, Brevibus, and Ethiopian Heirloom. And so that's the sample. So the question is, how do they taste, right? And in order to answer that question, we did the descriptor development, and we decided that these needs to be scored, and that's where I said that there was a lot of descriptors, 13. So they were scored on intensity of cereal/malt, nuttiness, bitterness, astringency, red berry, green apple, acidic, blackberry, sweetness, fruitiness, florality, and bergamot. That's the red dots. And by looking at this chart, you can see how they tasted by just looking at the spatial closeness or distance. So you can see here the Ethiopian Heirloom tastes mostly like bergamot and was the most floral and also fruity. I'm looking at the x-axis here. You can see the x-axis explains 72%, so and the y-axis only 16%. So the Ethiopian Heirloom was high in bergamot, floral, and fruitiness. The Robusta actually tastes really nice. It tasted more like if somebody told me it was just a nice Brazil, I would have believed them. A Brazil Pulp Natural. It was really nice and sweet. But this one correlated most with cereal, malt, and nuttiness, which is not a surprise. And then you can see the Caturra, Liberica, and Brevibus is not that separated, but it's more correlating with green apple, red berry, blackberry, and fruitiness. But this is just a big overview that gives you an idea of how it tastes, and it's based on all the data that the panel has collected. And you can also get this spider plot and get an idea per descriptor if it was any different at all. If each descriptor gave any statistical differences. And here you can see that red berry, sweetness, and bitterness and astringency didn't change beyond chance. You can see there are some differences, but the differences are not big enough to convince the statistics that it's not just a noise. So you need in an ANOVA analysis here to get a p-value lower than 5% or lower than 0.05. You need to have shifted the mean of a descriptor beyond the noise that you see in the data set. So here you can see it was really good data that we got. And you can see here, here we are looking per descriptor. Here we're just looking overall per descriptor. But here we are looking per descriptor if there are significance categories. You can see here, for example, acidity. The Robusta stood out and all the others were not really different. The differences here were not bigger than the noise in the data set. And you can see the same for astringency. It didn't seem like it stood out. But for bergamot, you could see here bergamot, you could see there was one that really stood out here. And that was the Ethiopian Heirloom, where all of the others were pretty similar. And you can see, for example, florality. There was 3 significance categories. So Robusta and had its own. Had an A label. That means that it it only has it has its own category, where the F hybrid, Caturra and Liberica, seem to belong to the same group from a statistical significant perspective, and the Brevibus and the heirloom, Ethiopian heirloom, had their own significance category. So here you can really go and analyze per descriptor how they behave. So can you see, this is amazing data, right? You can really understand each sample per descriptor. But remember, so that was the properties of the samples. Now we are looking at the properties of the individuals, because everybody tasted the same sample 3 times without knowing it. And they had to score the same descriptors per replicate. So here you can see the scoring of each individual person. So you can see here assessor 280. The assessor 280 was served the Brevibus sample 3 times and scored the Brevibus 3 times on the same descriptor without knowing which sample they tasted. So you can see here florality. The person got the same sample 3 times and scored florality very different every time. It was scored, once it was scored 2 in intensity, once it was scored 6, and another scoring was 8 for the same sample, same descriptor. So you can see here, this is variation. It's also called mean standard error later in the data set, but that's basically variation. But you can see here, for example, astringency. This person really scored astringency the same every time, all 3 times, so that's good. And you can see acidity, it was only 8 and 10. So that was not all over the place like florality. I think I should find another descriptor to talk about. For example, the green apple here, you can see for Liberica, this person scored it 0 and 6, the same sample. That is really confusing, but sweetness was more consistent. So this is just to show you, we've got the data per person. Every participant in this has their own data set like this. And you can see also this person for Caturra cereal malt was also all over the place. And this is per assessor, per sample. So you can see we have a huge data set on how well each assessor was consistent, but also you can also see the panel average here is the gray dot. So we've got all the data about the individuals and also about the panel. So I want to show you a slide that prepares you to understand the next plot. So you can see here in the data set, I anticipated for you the assessment of variation per assessor, right? So you can see here, if the person tasted 3 samples, let's just say light, medium, or dark roast, or it could be the Robusta Liberica and Ethiopian heirloom, or whatever, 3 different samples in the same data set. You can see here that the person can have a big variation. Variation is never good because it seems like people actually don't know, they're taking random decisions, right? Which is not good. But so here you've got a high variation. But you can also have a data set where the person is very consistent, but they score the different samples the same. So the p-value is the value that assesses if the person is scoring the different samples differently per descriptor. It's very important that the person is consistent. Every time the same person gets the same sample, scoring the same descriptor, the person should score it the same. But when the same person gets another sample, the same descriptor should be scored very differently. So there are 2 different skills. There's discriminability and variation. So variation should be low, And as I mentioned earlier, the p-value should also be low because that proves that the data are moved, the data set is moved per descriptor per sample, so that we can see the person was actually able to score different samples differently, consistently. So you can see you can have a high p-value. That is when you cannot see that the person was able to use the descriptor to separate the samples. And you can also have a high variation, high MSE. So you can see the first example here is an example of a high P, which is not good. You want a low one, but also a high variation, which you don't want either. Then you can see the second plot here shows a low variation. You can see that's great. There's a low variation here, but it doesn't seem that the person was able to discriminate the samples based on the descriptor, for example, acidity like here. But you can see that the statistics can actually accept some variation as long as there's a clear shift. If there's a clear shift, you can still accept some variation. So you'll get a low p-value if there's a clear trend in the data set. And of course, if you have a clear trend in the data set and low variation, that's the best, right? So you want to have a low p-value and a low MSE value. A low p-value shows that you are able to shift your scoring every time you get a different samples on the same descriptor. And a low variation shows that you have generally just you score the same. You're very consistent. I hope this is clear. It's actually a slide I made this morning because I always find it difficult to explain the next slide, because this is actually that plot per person. So you can see assessor 131. You can just see in the data that there's a big variation, and you can also see there's not a really clear shift in the data. Whereas if you look at assessor 280, it seems like there's a clear shift in the data set. So this person has a lower p-value for acidity and a somewhat low also variation. So this is a way each person can see how they did. But the best thing is that this can be shown in a PMSE plot like this. So this plot actually is a way of explaining these data that I just showed you. So you can see here, for example, this person, for sweetness, for example, that's a basic taste. Sweetness you really need to be good at. The basic taste needs to be good, right? You need to have a low variation, that's the x-axis, and the y-axis is the p-value. So you want both axes, you want all the descriptors to be in the lower left corner, because this is where you show that you have the skills. So in the lower left corner, this is the way your data looks like, right? Low P, low MSE. And then you can have any combination of low P or high MSE or high P and low MSE. And this is what your data set looks like if that's the case. So you can see here, this person really needs to train sweetness. I would tell this person sweetness is too important to have a high variation, which is the x-axis, but also a high p-value. This person needs to train sweetness, red berry, and acidity as well. It's very important that basic taste needs to be in the lower left. Let's see, bitterness is also not too good for this person. It's 255. And this is something that we can see here, right? That bitterness, everything is just scored low. The person is not using the scale. And also have quite a bit of a variation. And acidity, again, it seems like it's just one big cloud with no discriminability. So this is the hearing test that I told you about. So you can see per person here, you can really see how you're performing. This is a person who needs a little training, right? Everything is in the lower left. And notice here the green and the yellow and the red line. That is the background average that we have, or the percentiles for the 120 students we've had through already. So you can see here, if you are below the horizontal green and to the left of the vertical, you are in the 25% top students. And you can see here, this is the 50% percentile, that's the yellow. and the red is the 75% percentile. So this is just to give people an idea of how they are performing. So you can see this is really useful information per person. This is something you want to know about yourself. And once you know what to train, you can quickly get better, because you need to train your weaknesses and not your strengths. So that was product properties, individual skills, and now we have the third section of the software, which is the panel calibration. And here you can see per descriptor, if there's somebody who is outside the panel average. So you can see here SSR 292 needs to be calibrated, because this person is adding noise because they are behaving differently than the overall panel. And you can see here for Bergamot, we need to train Assessor 131 and 255. And 281 for BlackBerry. So we can see per descriptor, who do I need to train? Because this is something that gives us worse data. We get better data if people make the same decisions. Then we quicker get low p-values. And even if we identify who needs to be trained, you can see here, for example, on nuttiness, Assessor 282. And we can see here, it seems like 282 just have a lot of variation, bigger variation than most of them, and is scoring higher. So this is explaining how they are different. So you can easily use this for training people. So you can participate in a session like this at Coffee Mind here in Copenhagen, or you can participate virtually. So this is what we are launching now. You just need a friend and an Ikawa or a bullet. Then I can instruct your friend in preparing everything, and our software can gather the data. So it's a one-day full immersion with this methodology. There's more than this, but this is just one of the things that we're doing. So what this will give you, it's going to make you trust your own sensory judgment. And you can lead and you can make your own decisions and skip all the paperwork that I talked about. So it seems like sensory is kind of equated with paperwork, where we want you to focus on your own skills. And once you trust your decisions, you don't need the paperwork. And it gives you clear personal feedback on your sensory strength and weaknesses, so you can know exactly what to train and what to ignore. This is very important. Most people, they hide their insecurity in talking about fancy descriptors, where what you really need to know is, how am I doing for the basic taste and the flavor categories? If you are not making consistent data, you need to know your weaknesses, because you train, by training your weaknesses, you definitely get are on a steeper learning curve. And it's based on a science-based system, and there's no guessing. And if you are able to make your own decisions, you can also kind of step out of the whole guru worship kind of tendency there is, where you need to calibrate up against some other self kind of mentioned expert and make your own decisions. So that's really what we want to do, and this is very important as coffee roasters as well, because many people are just following somebody else's curve. I want you to make your own curves, and you can only do that if you trust your own evaluation of your roast profiles. So the method that we're using is using the exact same scientific method that has been used at the universities for 50 years. So we haven't invented this. This is just we're bringing science to the community. And it gives you instant feedback, like a hearing test, so you know where you stand. And basically it helps you kind of break free of what I call the copying form tyranny. And it's designed for people who have an Ikawa or a bullet, that's the virtual part, or you can just join us here in Copenhagen. So you can see here, you can either join us at the 4-day SCA Roasting Professional or the 1-day Sensory Performance. Of course, you need to travel here, so there's travel and hotel. But then you can join us here for 4 days, where we are roasting and doing a lot of sensory training. But you can also go virtual. It's a one-day event, and you just need an Ikawa or a bullet and a friend and colleague that we will instruct on how to prepare the samples for you. By joining this session here, I've made a small bundle for you so that you, by securing your seat in this funnel, if you follow this link, the leadme /free PDF, as you can see here. Oh, I better, just a second. You can follow this link, or you can scan this QR code. That takes you to a place where you can just register, in which case, if you haven't already, you will get a free version of this PDF that I've created with a lot of practical guidance on roasting and sensory, and also 2 scientific articles that you will get for free. And on the next page, you get an option to throw down 300 euros that will give you access to any future date. So you don't need to choose the date yet. Just you'll get a voucher for any future course, regardless if it's on-site or virtual. And because you get it here as part of this event, you'll get all our scientific papers, a collection worth at least 100 euros if you had to get them behind the the journal paywalls. And you will also get EDA's Sensory Basic e-learnings course for free. So you only pay 300 euros for a seat that you can always reserve later once you are in your calendar. So you will basically save 140 euro if you buy your free seat, your seat now that you can use for any future course. So leaving this slide on, I just want to do some Q&A with you. So Emma, you kindly let me know that astronomy is the science, astrology is the human personalities based on planets. Yeah, thanks for the clarification. So what do you think about all this? What's your thought on the what I just told you in terms of the scientific methodology? But also what your experience with the Q-grader system, which is based on the old 2004 SCA cupping form, and the new CVA system. Have you tried any of the? Have you tried the new SCA CVA system? I've only spoken to people who've done it. I haven't tried it myself. And then people could say that, well, then I shouldn't have an opinion. But if you are deep in sensory methodology, I think that you can still have an opinion based on all the points that I mentioned earlier. All right. No questions this far? I mean, it's a pretty controversial topic, so I'm surprised if people don't have an opinion. And you're very welcome to criticize everything I've said, because as a scientist, you have an opinion based on basically based on your own conviction that is resting on proven methodology. So science is trying to use existing methodology as well as possible to answer questions. And the question is, if there should be any criticism about my approach, it would be my ability or lack thereof of deriving from the classics, the best practices, the methodology correctly. So perhaps I've misunderstood something about classical sensory science that make me create wrong conclusions here. And as of now, it's a bit, there's not a lot of, I think I haven't experienced any pushback on the things that I've said. It might be because nobody hears it, or that it's not very, yeah, it's still early days. Or there is not a lot of understanding of sensory methodology as such, which means that when I kind of try to criticize these models based on sensory science, people don't know how to basically answer those questions. I don't know. I'm not the one to kind of answer that question, but I would really like to have some more dialogue about this. And we are planning a lot of events. Nobody is really asking about anything. So I can show you some data set that we did. Let's see here. Oh, this is on roasting professional. Well, I've done some data with the Coffee Collective here in Copenhagen, and we have done some sensory descriptive analysis of their coffees, and we've actually made a statistical model of how they price their coffee per descriptor. So we can see how they what descriptors they value and what descriptors they don't value. So we can actually see in this data set the price they wanted to pay on the coffee just based on the intensity of the different descriptors. All right. Well, I don't know if I haven't pissed anybody off since there are no questions, or if the ones being pissed off already left. But thank you very much for joining, and hope to see you at some point, either here in Copenhagen or at one of the many coffee events